Hello, my name is Jordan Shannon. For this project, I looked at three long-term temperature data from three NASA GISS climate stations to see if climate change is happening in my home region and whether it is the same way everywhere else. I chose three locations: Gainesville, Texas, Charleston City, which is at a similar latitude, and I believe it's pronounced Pembina, which is much farther north. The data shows the mean annual temperature from 1880 to 2025. So this graph shows the mean annual temperature from Gainesville, Texas from 1880 to 2025. The points show how temperature changes each year, and the straight lines show the long-term trend. This trend has a slope of negative 0.005 degrees Celsius per year, which means there is a slight cooling trend over the whole period. The R squared value is only 0.0617. So the trend line explains little of the changes in the data. Although there is a small negative slope, the overall trend is weak, and temperatures in Gainesville have remained fairly stable over the last 145-year record. Short-term ups and downs are much stronger than the long-term trend. So this suggests that local climate variability and other factors may strongly influence temperature in this region. So on this graph, it shows the mean annual temperature at Charleston City, which is about the same level as Gainesville, but at a different longitude. This trend line for Charleston City has a positive slope of 0.0035 degrees Celsius per year, indicating a slight warming trend over time. The R squared value is 0.0566, which means the warming trend is weak and most temperature variation is still due to short-term or natural fluctuations rather than strong long-term change. Compared to Gainesville, which had a slight cooling trend, this shows that climate change is not happening the same everywhere, even at similar latitudes. Excuse me if I'm pronouncing this wrong, but Pembina is much further north at a higher latitude. The graph shows a much more noticeable warming trend here. The trend line slope is 0.0175 degrees Celsius per year, much higher than at the other two locations. Over a century, Pembina has warmed by about 1.75 degrees Celsius. The R squared value is 0.2826, much higher than at the other locations. This means the warming trend explains a bigger part of the temperature change at this station. This provides strong evidence that higher latitude regions are warming faster than lower latitude regions, which is consistent with what scientists have reported about Arctic amplification. So on this slide, I show all three: Pembina, Charleston City, and Gainesville, Texas. I show all the data just in one so you can kind of get a idea of it side by side. So based on my analysis, there is weak evidence of long-term climate change in my home region, which is Gainesville. The trending slope is slightly negative and the R squared value is very low, meaning there is no strong long-term warming or cooling signals. Instead, the data shows mostly natural year-to-year variation. This does not mean climate change is not happening globally, only that the signal is less clear at this or at my local station. My analysis refutes the idea that climate change is happening uniformly, though, everywhere consistently. Charleston, at a similar latitude to Gainesville, shows a slightly warmer trend, while Gainesville shows a slightly cooling trend. This shows that locations at the same latitude can experience different climate trends. Pembina, which is much further north, shows a much stronger warming trend than both other locations. This does support the idea that higher latitude locations are experiencing faster rates of climate change. These differences demonstrate that climate change varies by region and is not evenly distributed across the globe. Overall, this analysis supports the scientific understanding that while climate change is a global issue, its impacts are regional and more intense in higher latitude areas. Based on current climate models and emission trends, average global temperatures are expected to continue to increase throughout the 21st century. By 2050 to 2100, global temperatures could rise by 1.5 degrees Celsius to 2.5 degrees Celsius, or 2.7 degrees Fahrenheit to 4.5 degrees Fahrenheit. More compared to pre-industrial levels, depending on how you look at it, or depending on the actions taken to reduce greenhouse gas emissions. This rise in temperature will lead to hotter and longer heat waves, warmer winters, and increased ocean temperatures. As well, the rising temperatures will have major environmental, economic, and social impacts, including increased sea level threats to coastal communities, more frequent extreme weather events such as hurricanes, droughts, wildfires, thunderstorms, tornadoes, things of that nature, and damage to ecosystems and loss of biodiversity, higher costs for agriculture, energy use, and infrastructure. If temperatures continue to rise at this rate, climate risk will increase significantly, while healthy ecosystems and stable environments will decline unless stronger action is taken. These are the two citations that I used for my report. Thank you for listening, and I hope that you have a great day.